Hi, in this video we will go through how to approach the problem formulation. I think this is an important thing to talk about because there's a difference between how researchers approach this and how an engineer will approach it. And what you find on the internet is usually how a researcher would approach it. So for the theory, there is a difference between a researcher's hypothesis and the engineering method of scoping a problem. So what we as engineers usually do is we state the problem that our product will address. Please be careful. Do not mention or focus on a specific product or solution at this point. The focus should be on the problem. Two parts that I would like to see in a problem formulation is if it is a specific customer or end user that you mention who this end user is, and second, the problem or the challenge that you will solve. So you may ask yourself, what is my reason for creating a problem formulation? Isn't it just to make my supervisor happy? But I disagree with that. So in my opinion, the problem formulation is the goal you're working towards, you and maybe with a couple of team members. Make sure that you and your team members are on the same level. What is the problem that you're going to work on? There might be some misunderstandings, and when you put them into writing, those misunderstandings might become clear to you. So your problem formulation is good because you can go back to it and consider, so is what I'm doing right now helping me getting closer to solving this problem? Then, of course, it's also for your supervisor and for your censor. Help them understand the context for the choices you make in your project. Finally, you might think that the problem analysis already covered this, but this is kind of a sum up of the problem analysis, but focusing only on the parts that you're actually going to work on. So with that in mind, your problem formulation is where you scope for what you will work on. There might be other issues you identified during your analysis, but this is what you're actually going to work on. Finally, a good problem formulation also helps you write that very good conclusion to your project. Obviously, all points in your problem formulation need to be addressed directly in your conclusion. Now, how do you write your problem formulation? When you sit with a blank piece of paper, it might be difficult to get started. Personally, I like to use the icebreaker. I write the sentence, the purpose of the project is, and then I just finish that sentence. That's my problem formulations. In typically one sentence, it might be 2 to 4 lines long. Some universities like to break down this problem into sub-problems. That actually makes it an achievable task. You could write, in order to succeed, the following must be carried out. And then comes your sub-problems. So I would look at a breakdown of the work I think I'm going to need to do. And then I will have 2 different parts of sub-problems in my problem formulation. One part is, how do we achieve the elements of the product? So how do we make it waterproof? A second kind of sub-problem, a second type is, what do we need to know or what do we need to find out to solve the problem in an optimal or balanced way? For example, if current customers get dizzy when using the existing products. You might have to look into what makes people feel dizzy, because only by understanding that can you create a product that doesn't make your customers feel dizzy. Okay, so now let's get started on that blank piece of paper. For this problem formulation, I would like to use one of our previous projects as an example. And it's an underwater robot to sail under the sea ice, dock against the sea ice, and then perform some measurements on the ice algae. Oh, this is difficult to get started with, so I will write. The purpose of the project is to measure the transmitted light through sea ice. As an indicator for ice algae growth by using a remote controlled underwater platform with sensors mounted. So this got me started. Now let's think. I don't want any solutions to be already included. Remote controlled, well, we don't really know that yet. It might be semi-autonomous or autonomous. It definitely has to be underwater. I actually wanted to write underwater robot, but I don't know yet what it will be, so I think platform is more general. I don't really have the customer identified, do I? The platform will be used on Greenland by Arctic bioscience researchers. So I could continue rewriting here, and you probably will do a few more iterations before you have your final problem formulation compared to what I'm doing here. But I think you get the point. And I think you are now beyond the blank paper. You got started, and that's the important point. So let's make some sub-questions. For the sub-questions, I copied in my guiding text, and I'll paste it right here to be modified. I think this sentence fits quite neatly. In order to succeed, the following must be carried out. Let's see, what work do we have to do? There's something about it needs to be watertight. These ice algae, they might be disturbed by our platform, so we have to look into that. What disturbs the ice algae and what's okay? Also the light sensors, they probably have some kind of field of view, they have some focus length, stuff like that. We need to find out what are the requirements given by the light spectrum analyzer. Let's call them installation effects. How do we make sure we have the same distance to the ice every time? Which light spectrum analyzer installation effects should we be aware of and avoid? How much fluid velocity will disturb or possibly damage the ice algae? How do we encapsulate the electronics to make it watertight? How do we move the sensor below the sea ice? So what other elements of the product do we need to achieve? Well, we need to know the location we are measuring, because the researchers want to measure above ice at that same location, so we can compare above and below. So there might be more problems to solve, but I think this gives you a fair idea of elements of the product that you need to achieve. So for the second part, it's about what you need to know or what you need to find out in order to solve your problem in an optimal way. And definitely we need to know more about the conditions on the sea ice and what limitations does that introduce on the component choices. Actually, this one about the damaging the ice algae is actually something we need to find out. It's not an element of our product. So there you have it. A few examples of sub-questions, semi-final problem formulation, and definitely a start that you can then work on improving. Thank you.